Welcome. We're very pleased that you're able to join our third Balmain Institute webinar presentation. And we're delighted to welcome Professor Veena Sahajwalla as our speaker this evening. For those of you who are new to the Balmain Institute, here's a brief word. The BI was formed to promote community discussion of local and global issues through monthly presentations, and we normally would meet at the Balmain Town Hall. We're a progressive and voluntary organisation independent of political affiliation. We miss seeing you, we miss having a glass of wine with you, but we hope that these webinars will keep us in touch, even virtually. We've invited you all to participate freely in these presentations, but they do involve costs for us, and we're very grateful to those of you who do make donations. If you can do that, please help us in this way. You'll find our bank details in the email that we've sent to you. Tonight's presentation will be recorded, and in the next email you receive from us, you'll receive a link to the YouTube video. If you have questions for Professor Sahajwalla during this presentation, please write them into the Q&A function that you'll find at the bottom of your screen. Keep the wording brief and we'll try to answer all your questions at the end of the presentation. Now, the Balmain Institute acknowledges that we meet on the lands of the Wongal people of the Eora Nation, traditional owners of the lands of Balmain and Birch Grove. We also acknowledge the lands of those who are attending this presentation from other places. We pay our respects to the elders of these lands, past, present and emerging. These lands were, are and always will be Aboriginal lands, never ceded. May we walk these lands gently and in peace. May we support the recognition of the Uluru Statement from the heart, and may we always remember that Black Lives Matter. I now hand over to Mo McCarthy to introduce Professor Sahajwalla.
Well, thank you, Margaret. It's a pleasure to introduce our speaker tonight, Professor Veena Sahajwalla. She's a renowned scientist, engineer, innovator, and science communicator. She's probably best well known for her work in the creation of the new science and micro-recycling and the attendant microfactories that go with it. She's well known for many of her activities, and we are pleased that she's with us tonight. She's currently a professor of material engineering in the Faculty of Science at UNSW. She's a foundation director of the Sustainable Materials Research and Technology Center. She's the director of the Australian Research Center Green Manufacturing Research Hub, which brings together scientists and industry to create forms of environmentally friendly technologies. Among her many awards and recognitions, I'd like to just mention a few out of so many. She has been the winner of the prestigious Australian Council Laureate Fellowship. She's the first woman to be acknowledged and awarded the Jubilee Professional Award by the Indian Academy of Science. She's a fellow of the Australian Academy of Science, and she has many more awards as well. She's the author of over 380 scientific articles. As an innovator, she and her team have been instrumental in creating new ways of using landfill to generate new forms of resources, like filaments of practice, that are essential in the creation of new products, like the face shields that are used by our frontline workers in the fight of the coronavirus. She has also created small mobile modular recycling factories that can be taken to the landfill sites and used there to function. They're small, but they're big enough to do the job. This innovation has a potential of destabilizing or disrupting the large-scale vertically integrated manufacturers and waste management operations. In addition, it has the potential of creating new supply lines, new markets, and products, all made from waste. Australia generates 67 million tons of waste per year. That's 2.7 tons per person. Treating waste as a resource and not simply as a problem obviously makes a huge difference to the future of our country and to many other countries around the world that are adopting these technologies. The environmental benefits of this are substantial as well. Often overlooked but critically important is her skill and commitment to operating as a science communicator. You've seen her on the drum or on the TV program, the Science Innovators, and it speaks to her commitment and willingness to share her ideas and her work that she's doing with local audiences like ours to help us understand the role of science and its contribution to how we live our lives and what we can expect from the future. We live in a world that seems to only generate problems, but through the work that Professor Sahajwalla is doing, we can see that there is potential for hope and there are changes that can be made that can be for the good and not simply problematic. So Professor, it's over to you and welcome again.
Thank you very much, Mo and Margaret, for very kindly inviting me here today and for really the opportunity to share some of my passion with you and your audience. It's an absolute privilege to be here. And I think one of the things that I love about the work that I do is it's taking what I'm really passionate about and the opportunity and the privilege, of course, to speak to audiences such as yours. And I think one of the things that you so beautifully articulated in the introduction is it's waste as seen as a waste can be a problem thing, but if you actually see it as an opportunity and do something positive with this opportunity, we can certainly shift the way we have our conversations. But I think it's very important that we don't just see it as, you know, here's waste that's got to be recycled, and if we can't recycle it, we're just going to throw it into the too hard basket, which sometimes, of course, ends up in our backyard, in our landfills. So I think it's also timely that we start to have that shift in the conversation where if waste materials are seen as resources, and if they can be put into production and put into manufacturing, then we can certainly see that in a value-added manner. So that's really where microfactories have come to life. We at UNSW are in fact prototyping and developing these microfactories and trialing and testing all kinds of new ideas. But of course, any new idea has to be first developed in a lab. The science has to be done. And this is where, of course, the work that my colleagues, myself at the Smart Center, we get excited about. But I think equally importantly, we get excited about the fact that there are so many businesses who, of course, see this as a fabulous way to contribute to new scientific ideas, to contribute to that wealth of the country in an intellectual sense. So I think first and foremost, we need to recognize that science as a foundation, of course, can be developed in partnership and collaboration. And I think together, we're certainly stronger. And so the fact that our industry partners, contribute their experience and their expertise towards this collaborative effort. So the Australian Research Council has funded this research hub on green manufacturing over the last several years. So from our point of view, our industry partners, whether they're in the business of recycling waste or whether they're in the business of manufacturing, have seen this tremendous opportunity for us to be able to take our waste resources and really use it for production. And the important, I guess, benefit for the country out of these types of concepts is not only are we then able to recycle and reform our waste, but equally importantly, we're able to then look at how we might be able to generate new jobs that are built on the foundation of science, but are also built on the foundation of our ability to recycle waste materials into value-added products. So that whole notion that, complex waste materials, and I'll pick on, examples like our electronic waste, these types of complex waste materials, can be seen as too hard, and therefore traditionally in many instances, we've chosen to ignore what we can do with it. I mean, even simple things like plastics that are there in our printers. Now that is a great form of a very useful device. Our printers, for example, enable us to do work in our offices, in our homes, in our hospitals. So we talk about electronics more broadly. It's just such an important part of our lives. So we can't afford to see electronic devices when they become obsolete or when they stop working as simply waste materials, because inherently the materials that are there in our devices are plastics that I was talking about, metallics like copper. All of these materials are still very much present and are useful even though the devices might stop working. So the whole point of looking at this whole new science of micro-recycling is to be able to say, can we actually take these really useful materials, and plastics and glass and metals, of course, are part and parcel. And certainly, we do see glass. That's our interface. And in fact, that's probably how you're seeing the program tonight from your homes through that interface of glass. But controlling all of that is circuits. And so there are important metals in there. But how do you then get down to those small details of our devices and recycle it? And this is where, of course, micro-recycling comes in. That micro-recycling is actually recognizing that when products undergo transformation, you can always look at how products might change with time. What that then means is you can take materials that exist in our systems, in our devices, but use those materials to constantly create new products. And in so doing, what we are actually doing is we're enabling that whole circular economy to continuously provide materials from our waste piles and those resources that, of course, if they are going to be really useful, we actually shouldn't even be calling it a waste. We should in fact be looking at these materials as fabulous resources. So I've talked about electronics. And then the other all-important system that we all use, of course, is our automobiles, our cars, and all kinds of transport systems. So you can imagine there's a lot of waste glass. I mean, the humble windscreen that we have in our cars, when you have a damage that takes place in case of an accident where you've got a crack in your windshield, you would often sort of get that repaired, or you might indeed have to replace it. So you can imagine that even, replacement of parts, your windshields, your bumper bars, just simple things like that you have to do, of course, as part of everyday life. You can imagine that once you replace these parts, the parts that have been damaged, of course, if you don't recycle it, they might end up in landfill. So all of these are just things that you can stop to imagine what they might indeed become at the end of life, their useful lives. Not a waste pile, but rather very much our ability to actually utilize products that indeed are important products in our life. So I wanted to, of course, just share with you and give you that sense of what happens, when we actually start to imagine a whole range of different types of systems that we use in our lives. So, here's a simple example where you might be able to see a whole pile of cars. And of course, when you look at something in that enormity, you suddenly start to realize that this is an enormous opportunity, because as we were talking before, we don't want to simply end up throwing away these types of materials into landfill. And I wanted to particularly share this screen with you, and I hope you can see this, but it's an interesting way to imagine what does this glass in our automobile actually look like. So what you see there is a picture of your windshield that has been damaged in case of an accident. But of course, you also see that sandwich of blue and light layer. That is what the windshield is all about. It's very much a sandwich kind of structure where it's not a straightforward glass. And this is, of course, designed to be safety glass. And what that then means is that in case of an accident, when the glass is actually damaged, that glass doesn't just splinter and throw shards everywhere. It actually cracks, but it doesn't injure passengers in case of an accident. So the whole point of designing a complex piece of glass like this for our windshield is, of course, designed to keep us all safe. So you can, of course, imagine that when you've got a complicated glass like that, it's not as straightforward to say, right, it's just any old glass and let's just put it all together and it's all recyclable. It's not as simple as that, because in that sandwich structure, what you actually have in the middle is a layer of a plastic. And that's the reason why this beautifully structured and designed glass keeps us safe. So you might say, okay, well, what happens to all these glasses after, of course, it comes off our car and we walk away with a replaced brand new part, is that we're ending up with these piles of window glasses, windshield glasses. And you can imagine, of course, it's never that easy to recycle it. So in fact, one of the things we do in our smart center, and you can probably see this video, which is actually demonstrating how taking that complex mixture of glass and plastics, and right there in front of your eyes, what you're seeing is the ability to transform that, what looks like an impossible product of mixtures of glass and plastics to be recycled, suddenly reforming into brand new materials. And so the fact that this is happening right in front of our eyes, you can actually see that the complex ability to take difficult materials at a micro level and to reform that into new products is actually possible. And this is what we do. So what you can see right from the top part of the screen, where you're seeing, of course, the transformation over time. And mind you, it's happening very quickly within a matter of a minute or so. You can see, of course, right at the very bottom of the screen, what we had generated is metal alloys, brand new metal alloys, where we've taken that glass that is rich in silicon, and we've actually taken iron and we've created a whole new ferrosilicon alloy. So the reason why, of course, this is important is because this alloy, ferrosilicon alloy that you're seeing, is also in its own right a very useful material. So you can say we've reformed our waste glass and plastics, and through, of course, some very clever science and all of that transformative reactions, we've converted that into these types of really useful alloys. So I wanted to, of course, just continue to share some of these examples where you can indeed see from our perspective how we can indeed take advantage of what indeed is absolutely possible. So let me just again give you another little sort of snapshot into the world of devices. And here's a whole pile of electronic waste or e-waste. And again, in here you might look at a pile like that and go, gosh, these are these old monitors that are no longer in use. And of course, thrown in there, you'll see a few TVs. So you can actually start to see that from perspective of us as users of these systems. Once different types of products become obsolete and we buy new products, it then is ending up in many cases in piles of waste all across the world. So it's a real challenge, in society as to what do you do with these types of devices. And I particularly want to show you, a lot of these monitors that you're seeing on the screen for the reason that indeed it allows us to, appreciate, how much and the volumes of these types of materials that are indeed created just as part of normal use. So in this particular instance, of course, what we have is the ability to, of course, tap into a lot of that waste plastics that's there in these types of computer monitors. And indeed, some of the waste plastics that we have been using, these types of waste plastics are allowing us to recycle and reform them. But let me continue to share with you a little bit more in terms of what else is there inside our electronic devices. So you can see now you're looking at basically a whole pile of circuit boards that have, of course, again, been generated out of our electronic devices. And you might sort of pause there for a moment and think, gosh, what on earth happens to all of these types of circuit boards? Sadly, even though they're actually very rich in high quality copper, in many instances, that kind of processing is not necessarily being taken to full capacity globally. And there is a lot of waste coming out of the electronic sector that is being generated. So you can see that, you know, we've got endless supply, whether they come from our phones, our computers, and indeed a whole lot of electronic devices. So let me just share with you some information that UNEP has basically put out that says, that's United Nations Environment Program, that basically our ability to tap into some of these types of devices has got not only an environmental benefit, but also it's got tremendous opportunity from point of view of creating, you know, just economic benefits for our society. And so that's really another good reason why we should be looking at tapping into a lot of these types of electronic devices. And then, of course, the all-important question, what happens to our batteries? We've got a whole range of batteries. Of course, as you probably know, that there's tremendous opportunity for us to really tap into these types of batteries, because at the moment, in Australia and of course in many parts of the world, we're not doing nearly enough to tap into a lot of these high quality materials. So for us, of course, as a country that is so large in the landmass, you can imagine one of the big challenges also, quite unlike you know, other parts of the world where you might have massive concentration of population, like places in Europe. Whereas in Australia, you can imagine that transporting a lot of waste materials over long distances just doesn't make sense. So we can't afford to actually waste so much of our money and energy and effort in transporting waste over long distances. And this is where, of course, you know, really starting to look at that micro level detail in terms of what's actually available to us is so critical. So what I would like to, of course, do is also, as we've been developing some of these solutions, share with you what it indeed means for our economy and, of course, for the global economy, and particularly in times like this, as you can imagine, that, you know, everyone in the world is really looking for how we're going to create new jobs, how we're going to really create new opportunities and look at what the world is going to evolve into. But we've got to be very proactive and we've got to be very positive and keep that hope of what this type of waste could actually mean. We can't continue to just see business as usual, that constantly just generating waste and throwing those away. So what we are indeed showing through this particular graph here is that we've got tremendous opportunities, and in terms of millions and millions of tons of e-waste that is being generated globally, that the economic value in there is quite a significant amount to tap into. So I wanted to also just give you a bit of a sense of what it's like. What you're seeing in this, you know, in the screen in front of you there is again different types of waste resources that are present in our economy, and I guess from our perspective is to be able to just recognize that we're talking about 50 million tons and thereabouts that are produced every year. So I want to, of course, now move into give you a little bit of a feeling of what this might indeed look like from the context of our society, and if we were to actually set up these microfactories, what might these microfactories actually look like? So I'm going to see if I can indeed play this video for you, and if this is something that you'll be able to see, I'll just give you a bit of a commentary on what you're able to see. Is a bit of a sneak peek inside these microfactories that we're running at UNSW. So you can see lots of waste, of course, on these conveyor belts that have been generated indeed through these types of modular devices. So very compact units that then literally pull apart various components in our electronic devices, and then using automation, using all kinds of transformative technologies, we can then, you know, tap into the value that we can create. So what you're seeing on the screen right now is how we can create some pretty exciting alloys from indeed waste resources, and the small systems that we have. You can see these shiny red droplets right in front of you. These are basically examples of what is indeed possible from our metallic alloys. And what you're seeing right now in front of you is our ability to take waste plastics and create these plastic filaments. These plastic filaments are what are then being used for 3D printing. So you can see right there, being able to do 3D printing using plastic filaments out of waste, all happening right there in these microfactories. So the ability to actually create this kind of transformation, and again, to look more closely into how this 3D printing is actually working, you're seeing on one side is plastic waste that we've sourced from our printers. We've converted them into these plastic filaments that you're seeing, and those plastic filaments are then being fed into our 3D printers to print, in this case, spectacle frames. So all of these are basically examples of microfactories that are taking the science at a micro-recycling level and that concept, and using our modules in a microfactory to manufacture these products. So you might say, well, okay, you know, what are the benefits in our economy in doing so? You can, just to be able to give you a bit of a sense of the value that we're creating. That transformation means that we can create value from waste that is really worth not a lot of money to plastic filaments that can be worth, you know, anywhere from $30 a kilogram and upwards, to, of course, 3D printed products that can be really, really expensive. But the fact that you've now value added is such a fabulous way to see this as a resource and a way to generate local jobs and, of course, local manufacturing solutions. And I wanted to also show you some other examples of what our microfactories can do. So in this particular case, we're actually creating different types of products for our built environment. So on one side of the screen, you can see our acoustic panels, these beautiful blue colored panels that we've created out of waste textiles and waste wood, is an example of what can be done when you combine different types of materials. And on the top right hand corner, you can see that we've got basically glass-based panels. So that's combining waste glass, waste textiles for production of really hard ceramic products that of course we have now shown that it can indeed be installed in housing systems. So that's really another way to think about our ability to manufacture high quality products. And indeed, that's what we do in our microfactories. So just to give you a little bit more of a sense of what these products look like, we've created all kinds of furniture-based items, or indeed you see these beautiful ceramic tiles that we've created from waste glass and waste textiles, these hexagonal tiles. So a lot of these products are indeed present at the moment in and being used by our partners, Mervac, who've then installed these in their apartments. So just to give you a bit more of a flavor of what do they look like. So you can imagine those hex tiles on the wall. You can see that beautiful dining table there. All of these are examples of what is indeed possible, and the broader notion of creating these types of green ceramics that we are producing out of a combination of really very unlikely candidates. So we've got, on one hand, broken glass, we've got textile, and all of these products, of course, then can be created as a result of micro-recycling, combining different materials at a micro level. And to be able to get you a little bit more excited about what are some of the other products that we've created, these are some other beautiful examples. So I wanted to, of course, just kind of share with you, these experiences that we've had, which shows that it's ultimately the power lies in our hands. How we actually create these products, how we actually enable our manufacturers to take advantage of what we can do locally right here in Australia is an important outcome from our perspective. So I'm really excited. I want to acknowledge our recycling partners, people like Tezam, our manufacturing partners who have indeed supported the work, businesses like Molycop, who are located out at Newcastle, organizations like that who, of course, are absolutely supportive of research, but also are equally passionate about the fact that this research has to be translated into practice to see the kinds of benefits, to see how we might be able to create innovative and new jobs in our society. It is absolutely critical that we do that. So I want to, of course, ultimately share with you the fact that microfactories ultimately can create job and new job opportunities, of course. It is one of those classic things where, because it is decentralized, because it actually can be located in different parts of the country and indeed the world, we are now not only looking at how we might be able to continue to grow the science and microfactories at UNSW, but equally importantly, working with our regional partners. So indeed, one of our microfactories that we are working with our regional partner in Cootamundra is about looking at some of these glass and textile combination to be able to produce these beautiful green ceramic tiles that I was showing you earlier. So from the context of what this all means for Australia and for the world, it is absolutely doable. And you can imagine, whether you're in a big city or in a regional remote location, you can actually imagine that these types of recycling solutions at the micro level means that they are affordable. That's one important question. They actually can create value-added products. And what that then means, they can contribute positively to our economy, to our local economy. And of course, what that then means is play a very important role in creating local jobs. So, it's an absolute honor and a privilege for me to have so many of our incredibly fantastic industry partners, Australian businesses who actually, really are supportive of innovation and new science. And indeed, it goes to show it doesn't matter whether you're a large organization or a small company, you can actually play a very important role in really participating in a collaborative effort of science and delivering benefits for our environment and for our economy. And the fact that we are showing in many instances with these types of world first technologies, it's a way for us in Australia to be really proud of the fact that the world of science, technology, application, business, all of that can come together for the all-important reason that we care about our people, we care about our planet, and we do want to make sure that we can deliver win-win outcomes for both, for our people and for our planet. So thank you so much, really, for having me here, speak to you and share with you some of the journey that we've been through. Thank you.
Thank you so much, Veena. That was terrific. Now we have a number of questions for you.
Sure.
One of the questions is, how can we stop waste at the source? That is, reduce the amount of waste that is being created.
Yeah. So, and that's a very good question, because I think, what we've got to acknowledge is that we will always be using materials and products I gave examples of our computers and our cars. So all of these are important aspects in our life. Now, if we were to ensure that these types of materials don't get classified as waste, don't end up in landfill, we then have to actually work in a way that a lot of these materials are not simply thrown away where it's just seen as a problem, but rather to imagine a situation where different businesses, big and small, can utilize these types of materials so that when you're actually looking to replace your parts, we've talked about just basically parts in our car. If you're actually looking to replace your parts, like we've talked about, or replace components, we have to ask the question of your manufacturer, your service provider, whoever's providing you with that service has to be able to tell you. For example, if you go replace your tires, you can actually do a little bit of homework and find out who are the tire manufacturers or businesses who have actually signed up to the tire stewardship scheme in Australia. And you can actually go and ask what happens to these types of waste tires. So when your tire comes off your car, what you want to know is this is not ending up in landfill, but rather your service provider is making sure that it ends up in the right place. It ends up being recycled and reformed and being used. So it's very much about thinking about how different types of products are being treated. Just because you've given it away to a service provider and someone's replaced your tires or your windscreen glass doesn't mean that your responsibility has to stop there. And indeed, one of the things that you have to be able to do is proactively ask questions, do that homework, look at if there are product stewardship schemes that are available in the country. And indeed, with tires, there is Tire Stewardship Australia. And that's how you can actually inform yourself and make the right decisions in terms of, how your products, once they leave your hands, that how your products actually do get recycled and don't just end up in landfill. So it's about engaging proactively with those service providers.
Okay. Could you just speak a bit more about the tire stewardship scheme? I'm sure most of us haven't heard about it.
Sure. Yeah. So, just to sort of give you an example, a lot of the stewardship schemes that are there in the country, are really designed to be able to create policies that make it easier for citizens. So for people like us, we don't have the time to know, who's doing what. So what that then means is that product stewardship schemes, whether they're for tires or indeed batteries and so on and so forth, are all about understanding what are the right policies that are being created by these types of schemes. So what that then means is that schemes like that will actually, they are voluntary schemes, so not everyone has to sign up to it. These types of voluntary schemes means you already know by looking up on the websites of Tire Stewardship Australia, for example, to find out who are the members, who are the voluntary participants in a scheme like that. So when you look up, you find out how many basically companies are actually participating in these types of stewardship schemes. And that's really the important thing. If you've got these types of schemes and businesses are participating in these types of stewardship schemes for different types of products, then it means that you can actually go in and take your business to those types of providers where they might be participating in it. What, of course, has to happen as a result of that is that we have to start to see how these materials then are being recycled. So one of the technologies that we've developed here in Australia is, a technology for recycling tires in the process of making steel, which is where our green steel technology comes in. So that's an example of how recycling of tires does take place in Australia. And of course, for those who might be interested, is to go and see what kinds of innovative opportunities exist in Australia for recycling. So it's about informing yourself, even if there are no stewardship schemes, but to be able to understand what businesses are doing in a proactive manner.
Thank you. And there are about 3 questions here that relate to manufacturers and how manufacturers are taking up the technologies that you are generating. So one question is, are the manufacturers who are taking up your technologies new startups who are specifically focusing on your technologies, or are they existing manufacturing businesses that are taking a new direction? And I'll just add this other question at the same time. Does the business community see the opportunities, or are they focused on the problems of going in the directions you suggest?
Yes, so I think you can look at it this way, that we do have a whole range of different types of industry partners. So it may well be that you've got a business that has actually been predominantly doing collection of products, waste products. But now what they're looking to do is they're really looking to upcycle their materials. So even though they might have not been in the manufacturing business, but because they've been in the business of collecting waste, what they're really looking to do is set up new manufacturing facilities so that they can actually create more and more value-added products. So effectively, you can see that manufacturing part of their business as a brand new activity that they're undertaking, which actually goes to show that you don't have to be a traditional manufacturer to be able to start doing manufacturing. And this is where, of course, partnership and collaboration is so important. So you can start to see value creation. And if you have to create value, then you've got to be in the business of creating highly engineered, high valued product. So it's not enough to say, I'm going to collect waste and I'm just going to give it to somebody else to do something about it. So even if a small business like the one that I was referring to in Kuramandra is in the business of collecting waste, they're now setting themselves up to do manufacturing. The other example is our e-waste recycler, Tezam, in Sydney. So a company like that can be in the business of collecting plastics and metals and so on that come in from our electronic devices. But it takes really a lot of hard work and effort to then say, right, I'm now going to have a whole new system of manufacturing some high value products. So what that shows is that you can actually start to imagine a future that even if you were not necessarily a manufacturer, you can start to do it. Now, on the other hand, we've got some businesses who are currently manufacturers, and what they're looking towards our technology, like, for example, our green steel technology by the steelmaker Newcastle Molycop, is a good example where they're now looking to reduce their consumption of coal and coke by introducing our technology of recycled tires in this electric arc furnace steelmaking process. So you can be a manufacturer, and indeed in case of Molycop, they're more than 100 years old. So you can see that a manufacturer that has been around for a long time, but is now looking at adopting new cutting edge solutions. So it's always about, looking at new opportunities, new horizons. And it doesn't necessarily mean that you've got to fit a certain mold. And that's really the beauty of these types of technologies, that they're very agile and flexible. And you can take the parts that are relevant to your business. You don't have to do everything. You can take the pieces that matter to your business and kick that off to create new business opportunities. So the nice thing about looking at that full spectrum of businesses that we engage with, there certainly is tremendous opportunity. Just today, I was having a discussion with a woman who's actually collecting old uniforms, and her new business as a small business owner that she's launched, which is called Worn Up, and she's basically looking at how she can take a lot of uniforms, as you can imagine, very good quality, consistent, whether they're school uniforms or uniforms from businesses. How do you take that waste textile and how do you then do something high value with it? Now, this is where, of course, she is someone who is literally started her business from a collection model, partnering with us, looking to partner and doing something that's of high value. So yeah, you can be absolutely a small business and do world-leading science.
Oh, good, thank you. Another question was asking whether or not you're involved with making PPE equipment.
So we were actually asked to prototype and trial. We, of course, have made these types of prototype ones from waste plastics. And that, of course, is the novelty of the work that we do, which is the ability to use these types of recycled plastics in the production. Of course, a lot of people are manufacturing PPE. I think for us, the challenge was not just about the making of the PPE, it was about how do we actually use our waste plastics in the production. So for us, it was very much, as you saw, was showing that 3D printing is how do you then take waste plastics and then put that through our microfactories to prototype some of these solutions. So we've actually had hospitals and clinics in New South Wales who've been very kind in saying, give it to us and we'll test out your prototypes. So we're in that phase where our ability to partner with medical professionals has been absolutely fantastic. Even right here in Sydney at St. Vincent's, we've had an amazing Dr. Annie Keogh, who's been just so fabulous in saying, you know, let's drive this, let's make this happen. And so I think what we've often been inspired by ourselves is there are so many people who are champions and really wanting to shift the way, you know, the norm is considered as the norm. So whether you're in a hospital or whether you're in a waste recycling facility, you have to have champions who are going to drive that change. And this is where we've been really fortunate.
How long do you think it'll be before the business community will be generating enough momentum that we really see the difference in the economy? You know, we're gradually making the inroads now, but how is that momentum going to increase, do you think?
Yeah, I think it's like everything else in life. You know, the people who go in there first with any new idea are always the brave and the bold ones, of course. And that's always something that, as I was saying, I call them our champions, because of course, you know, we could be doing the research at the University of New South Wales, but without these, you know, business champions and leaders, you know, people like Sharon out at TES and Andrew out at Cootamundra and Ian Tooze at Molycop. I mean, all of these are examples of businesses that are looking to be the first in their sector. And for us, what we are seeing is that this year has been a really critical year for us, because as we've been showing that these prototypes are working, the manufacturing systems are working, as we're setting up some of these new solutions, as we embark on the new year next year, we're actually going to be in a position that, you know, many of these opportunities will start to get commercialized. So I think a lot of the world's first technologies always need businesses who are prepared to be the world's first in many instances. So I think as we can see Australian businesses being really proactive, it actually goes to show that it won't be too long before, you know, Australia can lead the world and show to the rest of the world that it can be done.
Terrific. Well, that's very good. Thank you. Go ahead.
So here's a question. What are the energy costs of transforming these materials?
Yeah, you know, we often have to look at the product and how you make a product, because of course, the question is, in the manufacturing of any product, you need materials and you need energy. There is no question you need both of these resources. Now, we've talked a lot about using recycled materials. When it comes to energy, of course, we've got to keep in mind that in most cases, the energy that you use when you're doing recycling is a lot less than the energy that you would need if you are using virgin resources for manufacturing. So to give you a simple example, if you are recycling metals, like for example, steel, you would actually use a lot less energy if you are using waste steel and waste copper and so on in the manufacturing of new steel and new copper and new aluminium, compared to taking these types of ores out of the ground and creating those virgin metals. So in fact, the energy difference in many instances is quite remarkable, as in you save a lot of energy. So, you know, with metals like aluminium, for instance, the difference is remarkable. The amount of energy that you save in using recycled aluminium, you're saving 90% of energy in manufacturing. So, you know, you can just start to see, and of course, those numbers will vary depending on the material in question. So, you know, if you look at, and to be able to give you other examples, like in the case of our glass production, the temperature at which we are making those types of products that I showed in some of those pictures is a lot lower compared to the temperature that you would need to smelt that glass. So if you had to put it into a smelter and smelt it and do all of the things that you would do in a traditional sense, comparatively, the temperatures that we're using is much, much lower. So you can imagine that if your temperatures at which you manufacture those products is much lower, the energy consumption will be lower. So this is the point. It's about asking what kind of manufacturing process you need depending on the application. So some of those examples that I showed you, which were made out of recycled glass, why would you put it into a manufacturing process that requires a lot more energy? You're a lot better off evaluating some of these options where the energy consumption is a lot less. So that's the other important, you know, reason why recycling makes a lot of sense. And if I can just take a moment to explain why it takes a lot less energy when you use, let's say, recycled steel for production of new steel. When you take iron ore out of the ground, when you actually process the ore and then convert it into metal, that costs a lot of energy. So by the time you've actually made your metal, all of that energy is already embedded inside the metal. So by recycling a metal over and over again, you're actually using that material, but you're also using the energy that's already embedded in the making of that metal. So that act of recycling that metal over and over again means that you are actually saving a lot of energy because you don't have to go back again to step one. You actually have done the initial part of the journey. So of course the numbers will be quite different depending on the material. But that's a very important point. Another important reason why recycling actually is good for our environment.
Oh, very interesting. Thank you. I know there was some data that suggested that your steel plant in Newcastle, the green steel manufacturing, uses a lot less electricity than they have in the past, which was one of the reasons why they became so committed to using the new technology in the creation of green steel.
Yeah, well, I mean, you know, you look at businesses like that. I think from the context of whether you're a steel producer or an aluminium producer, you've got to be able to look at all the different, you know, reasons why you're consuming energy, right? So in the production of metals, which you normally have to consume, you know, energy, you're making it at a temperature that requires enough energy. You need power, and so this example of the plant in Newcastle is basically where they've now gone to using you know, more than 50% of renewable energy. So they've actually got you know, commitment to using renewable energy, and I think to me an example of, you know, what might be seen as a traditional company that's, as I said, you know, been around for more than 100 years, but now really looking at all kinds of innovations. And I know that you know, they have been very proactive in supporting all kinds of sustainable solutions. So for their own business to use renewable energy, and then to make this commitment to use green steel technology where you know, rubber injection will take place into their furnaces and will further reduce their consumption of coal and coke, is a really good example of how businesses can be really proactive and look at, you know, Australian inventions.
Yeah. Terrific. So really, this is the question that was asked is there a future for fly ash from power stations? Fly ash from power stations, or does it have to be stored longer?
Yeah, you know, it's a really good example of a material that inherently has got some uses. It's a question of how do how do you take advantage of it in a way that it makes both environmental sense as well as economic sense? So you've got to be able to make products where you're not transporting that fly ash over long distances, right? We talked about transport. Transport costs money. So you've got to also look at the opportunities where its conversion into a useful product can be done as much as possible in local areas. And so the reason why, of course, we've been talking about microfactories today is that it actually enables local communities to look at what might be possible within a reasonable distance from where the waste is located. So the ability to use some of the fly ash materials in infrastructure and built environment is certainly an area that a lot of researchers have been looking at as to how do you actually put that into civil and of course, infrastructure and various, applications. I think is something that people are looking at, and there is no reason why we can't continue to use a lot of fantastic science that's being done in Australia for these types of civil applications. So I'm absolutely positive about and see a lot of hope that a lot of good research that's happening in Australia can actually be adopted and taken up by end users.
Okay, good. Good. All right. Thank you so much. I wonder if you wouldn't mind just asking one more question that's
Sure.
Personal, actually. I read somewhere that you first thought about plastics when you were a child growing up in Mumbai. I wonder if you could just briefly say how you went from that query to where you are now as this mega innovator in recycling.
Yeah, no, that's a very good question. By nature, children are always very curious and inquisitive, and I think like any other child would, where you're sort of how much of your normal play and what you play with and what you engage and what you find interesting eventually kind of stays with you. But I think it's more about the fact that we need to always encourage kids to pursue what they're passionate about. And so, yes, in my case, I have always been passionate about looking at different types of products, and particularly, I remember also, it wasn't just about plastics, but also a lot of little glass bottles that I always found very fascinating. I'd have my own little collection of little medicine bottles and so on, which of course, are always interesting because, it's that fascination with these products because they all seem to come in different colors and shapes and sizes. And I think to me, it was always about sort of wondering how these things were actually made, because of course, you don't necessarily know the answer, but you do wonder about all the little things. And of course, you could say either I was really curious and inquisitive, or I was and continue to be to this day a big hoarder. I love to hoard things. so I love to be able to have my own little collection of different types of products. I still have my, coffee packaging that I'll collect. My beans that come in my 1 kilo bags for my coffee machine. I'll collect those and take them into work, or it may well be the packaging in which we go and buy these, oranges at Woolies, for example. I'll be collecting those netted, plastic bags in which our oranges come in. And I think all of that is really, in a way for us, you almost have to stop and ask that as a society, yes, we've evolved and we've grown and we love to consume these, but how do we go from there to, of course, making sure that we deliver sustainability for our planet? And so in my case, was very much about pursuing my love for science and engineering and the environment. So I followed all of that through North America. I did my studies in North America and Canada and US, and came to Australia when I got a job. So I think it was very much about, it was my first job, and I was like, oh my gosh,
All right.
So that's how we ended up here in Australia.
All right. Thank you so much, Professor, for your wonderful talk tonight and for explaining to us how microrecycling works and the microfactories. It's been a great privilege to have you with us, and we've enjoyed it very much, besides learning a lot. Before we go, I would like to thank our technical staff, Michelle and Stephen, who were on board for another problem-free evening. And I would like to thank everyone for their donations after these talks. We understand it's hard time for many people, but for people who could make a small donation, we'd appreciate it very much. The bank details for the Balmain Institute are on the bottom of the event announcements you receive. And I just wanted to mention our next speaker will be Dr. Bridget Busia from Macquarie University, who will be speaking on the politics and rhetoric of food policy, food security at global, national, and household levels. The meeting will be on Thursday, the 14th of August at 13th of August at 7 p.m. Look for the MailChimp announcements closer to the date. In the meantime, thanks for coming. Thank you again, Professor. Stay safe, everyone. Keep social distance, keep washing your hands, and stay well. Good night, and thank you.